Hello and welcome. I am Dr. Pauline Fu. In this video, I will present estimate population proportion. At the end of this lecture, you would be able to obtain a point estimate for population proportion. Construct and interpret confidence interval for the population proportion. Determine the sample size necessary for estimating a population proportion within a specified margin of error. Sorry, my dog is here. Oops. So let's introduce point estimate. It is the value of a statistic that estimates the value of a parameter. Remember what is a statistic? Some characteristics for sample. For example, sample mean is a statistic. Sample standard deviation is a statistic. Parameter, the characteristics of a population. For example, population mean is a parameter. Population standard deviation is a parameter. Oops, my dog is, oops. So the point estimate for population proportion, use this P bar, P hat represent the point estimate for population proportion equal to X over N. X is number of individuals in the sample with a specified characteristic. N is the sample size. Okay. For example, out of 100 students, I found that 65 students have part-time job. In this example, N equal to 100, X equal to 65. Okay. And the percentage of students having part-time job, P hat, equal to X over N. 65 over 100, 65%. Okay. So let's take a look at another example. Calculating a point estimate for population proportion. In July 2008, a university poll asked 1,783 registered voters nationwide whether they favored or opposed the death penalty for persons convicted of murder. 1,123 were in favor. So in this question, this number 1,783 is sample size. And 1,123 is people who are in favor of death penalty. So the question is, obtain a point estimate for proportion of registered voters nationwide who are in favor of the death penalty for persons convicted of murder. So based on the formula, P hat equal to X over N, and the result is 0.63. Hi, Nori, sorry. My little dog is sorry. So next, we'll introduce confidence interval. Okay. Confidence interval, it is an interval between two numbers. Okay. So this confidence interval, for example, I estimate the percentage of students having part-time job is maybe 60% to 70%. So that is the interval between 60% and 70% of students having part-time job. Okay. Confidence interval for unknown parameter. Okay, for example, population proportion consists of interval numbers based on a point estimate. Okay, so for example, based on the point estimate, the example I gave you here, out of 100 students, 65 have part-time job. So I have 55% of students having part-time job. This is the point estimate. Based on this point estimate, I can say maybe between 60% to 70% of students have part-time job. So this is an interval, two numbers, okay? And it is based on this point estimate. Of course, you can give another interval. You say, based on the point estimate, 65%, maybe the percentage of students having part-time job may be between 50% to maybe 75%. Okay, and this lecture will give you the scientific numbers. How do I prefer this number or do I prefer this number? Or you may get another interval. So we are going to use formula to calculate the confidence interval. Okay. So next terminology, the level of confidence. This represents the expected proportion of intervals that will contain the parameter if a large number of different samples is obtained. The level of confidence usually use 1 minus alpha times 100. Alpha is level of significance. Alpha is level of significance. And 1 minus alpha times 100, usually it is in the format of 90% or 95% or 99%. Those are three popular usage for level of confidence. So now, take a look at the example. 95% level of confidence. When you have 95% level of confidence, alpha equal to 0.05. Remember the name of alpha is significance level. Okay. So 95% level of confidence implies that if 100 different confidence intervals are conducted, if 100 different intervals, 100, okay? For example, here I'm giving you two intervals. Suppose you have 100 intervals, okay? So if 100 different confidence intervals are constructed, each based on a different sample from the same population, we would expect 95 of these intervals to contain the parameter, and 5 of those intervals does not contain the parameter. So that is the meaning of 95% level of confidence. Just adjust my table, computer position. Okay, good. Confidence interval estimate for population proportion use point estimate plus minus margin of error. Margin of error of a confidence interval estimate a parameter is a measure of how accurate the point estimate is. Using a graph, if this is a point average, point estimate, so, and if you get, based on this point average, you get confidence interval from this number to this number. Suppose the part-time job of students 65%. Based on this point, and you get confidence interval, the population percentage of students having part-time job anywhere between 60% to 70%. Okay. So in this diagram, which line represents margin of error? So from here to here, that is margin of error. Okay. So this is 5%. Margin of error is 5%. Okay. So when you use point estimate, 65% plus margin of error 5%, and you get 70%. You get 70%. Okay. And if you use 60%, 65% minus 5%, you get 60%. So that's how you can use point estimate and margin of error to get confidence interval. Margin of error depends on 3 factors. 1, level of confidence. If level of confidence increase, margin of error also increase. Okay. So for example, I am 90% confident to say that the population proportion of students having part-time job from 60% to 70%. That is based on 90%. Now I increase the confidence level. I say I am 95% confident to say that the percentage of students having part-time job is 50% to 70%. See, 50 to 70, you increase the margin of error when you increase the level of confidence. Sample size. As the sample size increase, the margin of error decrease. When you increase the sample size, the margin of error decrease. It is more concentrated. Okay, decrease. Standard deviation of population. The more spread in population, the wider interval will be for a given level of confidence. So the more spread the population, the more spread, the wider interval. And now, sampling distribution, p-hat. When you are talking about distribution for a statistic, usually you specify 3 things. 1, requirement. 2, mean. 3, standard deviation. Okay. So the requirement for sampling distribution of p-hat is NP times 1 minus P greater or equal to 10. P is the probability of success. Okay. For a random simple sample size N, the sampling distribution of p-hat is approximately normal. Okay. P-hat is normal. What is the mean of p-hat? The mean of p-hat, we use mu subscript p-hat equal to population proportion. The standard deviation of p-hat, we use sigma subscript p-hat equal to this one here. Okay, square root of p times 1 minus p divided by n. Okay. Also remember that to make sure each trial is independent, we also ask the sample size n is smaller than 5% of population size. The purpose is to make sure the trial is independent. beautiful today, beautiful weather today. Very sunny, and the birds are chirping loudly. Right. So now, how do we construct a confidence interval? Okay, for example, how do you construct 95% confidence interval? How do you construct 99% confidence interval? Okay. You use the formula. Okay, you need to create lower bound based on this formula. Upper bound is this formula. And what is p-hat? P-hat is sample proportion. Sample proportion. Okay. Z half alpha. What is Z half alpha? So I have to explain Z half alpha, I have to give you an example. Suppose you are asked to construct 95% confidence interval. Okay, you are asked to construct 95%. If you are given 95%, that means alpha equal to 5%. And alpha has a name, significance level. Alpha is 5%. When alpha is 5%, half alpha is 2.5%. 5%. Okay. And in a normal distribution, bell-shaped symmetry, what does the 95% mean? Means this is 95%, the central area is 95%, and where is the 2.5%? This little area here, and that is half alpha. So this area is half alpha. When you have this area is half alpha, there is and only one Z value corresponding to half alpha, and we call this point. This point is Z subscript half alpha. Okay. So let's do the calculation. Here, I'm giving you 95% confidence level. So I'm saying alpha 2.5%. When alpha is half alpha 2.5%, what is that half alpha? That is the question. So how to, given the area, you would be able to find a point here. Okay, from last lecture. You can use the table or you can use Excel. And remember, either the table or Excel, the value you get is the area to the area to the left. Okay, the table or Excel based on area to the left. So to find this point, we need to figure out what is this area to the left of this Z half alpha. So obviously this one is 97.5% because the little right tail area is 2.5%. Okay, and this percent is the same as 0.975. So we know the area to the left is 0.975. Go Excel. You can also use the table. Okay. So go Excel. Try to find what is this point Z value. Okay. So you use norm dot INV. Inverse normal distribution will give you the Z value or Z score. Probability is the area 0.975. Mean is 0. Standard deviation is 1 because we are using standard normal distribution. Okay. So you get 1.96. You get 1.96. Okay. So this area, so this point equal to 1.96 based on this formula, the Excel formula. So once you have this Z value, Z half alpha, sample proportion you can calculate, and then you have the result for lower bound and upper bound. And in this formula, we call this one is the margin of error. So this part is the margin of error. Of course, when you use this formula, this lower bound, upper bound, make sure check the requirements. NP hat times 1 minus P hat greater equal to 10, and sample size N smaller equal to 5% of population size. So let's take a look at this example. Construct a confidence interval for a population proportion. In July 2009, a university poll asked 1,783 registered voters nationwide whether they favored or opposed death penalty for persons convicted of murder. 1,123 were in favor. Obtain 90% confidence interval for proportion of registered voters nationwide who are in favor of the death penalty for persons convicted of murder. This is a very typical example. Given sample proportion, how do you construct confidence interval for population proportion? Okay. So you just need to use this formula. Okay. So in this formula, you need to identify P hat. Remember what is the P hat? P hat equal to X over N. X is 1,123. N 1,783. So you know what is P hat. Okay. And next, in this formula, we also need Z half alpha. So when you have 90% confidence interval, okay, so this is a 90% confidence interval. The question is, what is this Z half alpha? That is the question. When you have 90% confidence interval, what is this point? To find this point, we need to find the area to the left of this point. We need to find this area. Okay, and it turns out this area is 95%. Why? Because each tail is 5%. Okay. So once you have this 95%, you go Excel. Go to Excel. Equal norm.inv. Probability 0.95 means 95%. Mean is 0. Standard deviation is 1. Okay. And you get 1.645. Okay. So I'm going to just copy this. Okay. So y value equal to 1.645. All right. So you have the Z half alpha. What else do you need? You need N. We already have N here, 1,783. So you have all the number you need to calculate lower bound and upper bound. All right, and you can get number. So this is a complete solution. But before you do the calculation, make sure to check the requirements. NP hat 1 minus P hat greater or equal to 10. Okay. So that is the population proportion confidence interval estimate for population proportion. Last topic, we'll talk about sample size needed for specified margin of error, E. Okay. Remember, when you do a research project, you need to take sample. Okay. If the sample is too large, it costs lots of money, time, effort. If the sample size is too small, the sample does not have representation of the population. So how do you select appropriate sample size? You need to use this formula. Okay. You need to use this formula. In this formula, you have sample proportion P hat, sample proportion P hat, and you have Z half alpha. And E is margin of error, usually is given. Here, we have a dilemma. You can see this formula uses P hat. P hat depends on N, but we are asked to calculate for N. Okay? So how do we solve this dilemma? Two methods, two solutions. Okay? Solution 1, use an estimate P hat based on a pilot study or a historical data. Solution 2, use P hat equal to 0.5. When P hat equal to 0.5, it gives the largest possible value of N for a given level of confidence. When you calculate sample size, usually you need to round up to the next integer. P hat is the estimate. P hat is the sample proportion. It is an estimate of population proportion P. So now let's take a look at this example. Determining sample size. A sociologist wanted to determine the percentage of residents of America that only speak English at home. What sample size should be obtained if she wishes her estimate to be within 3 percentage points and with 90% confidence, assuming she uses the estimate obtained from the Census 2000 supplementary survey of 82.4%. So let's analyze the given numbers. Within 3% points, that means margin of error E equal to 3%. %90 confidence means Z half alpha is given. When you have 90% confidence, remember we just did this one. When you have 90%, say 90% confidence, Z half alpha 1.645. So Z 1.645. And the question asks us, P hat use 82.4%. See, you have 3 items you know, margin of error E, Z half alpha, and P hat. Plug in those 3 items into this formula. This formula needs 3 items, okay? E, Z half alpha, P hat, and you can calculate sample size, okay? And when you get a decimal place for sample size, always round up regardless. Okay. All right. In summary, what I did in this video, I did 3 things. 1, use point estimate for population proportion. 2, construct confidence interval estimate for population proportion, means interval 2 numbers. Okay. 3, calculate sample size. Okay. That's all for this lecture. Thank you so much for watching. See you next time.